Hi, I'm Terry VanNoy. Thanks again for visiting, and you're inside my online classroom, Math Class with Terry V. For a live session, the first one is free. You can give me a call or go to my website. I work with students in real time and answer their homework questions, develop skills, build the confidence, get them ready for tests, whatever they need. All right, let's take a look at this video. And we've been talking about hyperbolas, and now it's time for a problem set. All right. Quick review first of all. We've been doing conic sections, parabolas, circles, ellipses, and now hyperbolas. In the previous video in this series, hopefully you've seen it, we talked about what the equation of a hyperbola looks like and how that determines what the graph is. So just a reminder here, the equation of a hyperbola looks like this. Now first it looks kind of complicated, but basically it's an x group squared over a squared and a y group squared over b squared, and we want to make sure there's a subtraction there in between. Okay, and it always equals 1, and the h and the k value tell you where the center of the hyperbola is, and that'd be this area right here. The a value, so you have to take the square root of whatever's underneath here. The a value is the horizontal distance apart the vertex points are, and the b value provides the other dimension of a rectangle. And what you do, of course, you draw, as you can see in this diagram, you draw the diagonals. Those are called the asymptotes, which are sort of like the border lines. From the vertex, the curve goes up and approaches the asymptote forever, never quite gets there, and going down this direction and over on this other side too. So it's a set of curves that are a distances apart in both directions, and again the a and the b help provide the rectangle. So if you can figure out where the center is and where the rectangle is, then you've got it. Now I'm going to have you try a couple of examples here. Take a look. Alright, now as always in these problem sets, I expect that you'll pause the video and you're going to give this a try for a few seconds and then play the video and see if you're right, and I'll go over it with you. So let's try these first two. Go ahead. Alright, first of all, in the x group here it says x squared, and that means that it's really x minus 0 squared. Alright, so our h value has to be 0. And y plus 1, we need to rewrite that again as a subtraction value. So that's really y minus 1 squared. Therefore, the center, hk, has to be at 0, negative 1. Alright, so that's our first job. Locate the center. So 0, negative 1, it's going to be right there. Okay, also the a value is 5 because 25 is really 5 squared, right? Yes. And 16 is really 4 squared, so b must be 4. Now that's going to give us the dimensions of our rectangle from the center. So if a is 5, we're going to go 5 in this direction and 5 back in a negative direction. And then we're going to go 4 up and 4 down. Let's draw the rectangle. Alright, the rectangle is going to look like this. And now we can draw our asymptotes. So let's do that. The asymptotes are always in the diagonal distance here of that rectangle. And let's draw the curve. Alright, so from the vertex, we're going to have the line going here, approaching the asymptote, and going here, approaching the asymptote, and the same on the other side. So we're going to be basically doing something like that. Alright, so again, we find the a and the b value, we find the center, draw the square or the rectangle, and the diagonals. There you go. Alright, let's look at number 2. So we notice that it's x squared, so the h value has to be 0, and this is y squared, the k value has to be 0. That means the center is right here. Okay? Now the a value must be 2, because it says 4, we need to take the square root. And this is really y squared over 1, so that's why b is a 1 value. Alright? If you don't see it, it's a 1. So we're going to go 2 to the right and to the left, but 1 up and down. So there's my rectangle. Draw the diagonals, that's the asymptotes, and as you can see we have the hyperbola curve going here and here, opening to the left and opening to the right. Alright, very good. Let's try a couple more. Look at 3 and 4 and see if you can graph it. Alright, here's number 3, and let's watch the signs here. X plus 1 is actually x minus negative 1. Okay, ignore that line there. And so you're going to go back 1 from the origin, and this k value is a positive 3. So the center right there located at negative 1, 3. Now both of the a and the b values are 2, because that's 2 squared, right? And so you're going to go 2 to the right and left, 2 up and down, draw your square. The diagonals are your asymptotes, and remember the vertex right here, and that is where you draw your curve. So number 3 looks like that. Number 4, this is x minus negative 1, and so you're going to be center at negative 1, positive 1. There you go. This is giving you an a value of 3 and a b value of 2. So there we go. We're going to go horizontally 3 spaces in both directions, and up and down 2. Draw your square, draw your asymptotes diagonally, and again the vertex goes there, curving up towards the asymptote, down towards the other asymptote, and the other vertex is in a similar direction, opening from the left to the right, and there's your hyperbola. Alright, excellent. Now thank you so much for watching this video and working through these conic section curves with me. Now I want you to look for the next video in this series, which will say Self-Quiz 1. We're going to be looking at the graphs of some of these conic sections, see if we can come up with the equation. Alright, good luck and thanks for watching.